A precipitation reaction happens when a precipitate or an insoluble ionic salt is formed when two solutions are mixed. I've got a photograph here, and this is a precipitate of silver chloride. And we can tell quite clearly it's a precipitate because I can't see through the solution. It's cloudy. The solid is slowly starting to fall out of solution. And if this particular picture had been taken maybe 10, 20 minutes later, we'd expect to see a clear solution sitting above a pile of white silver chloride. I can make a precipitate of silver chloride by mixing together two solutions. Silver nitrate, which is soluble, and sodium chloride solution, which is also soluble. This AQ here indicates that my ions are in solution, so they are essentially bumbling about with a duvet or hydration shell of water molecules. So in reality, it would make better sense to write them out as separate ions, because to all intents and purposes, in their solution, they are completely separate ions. So when I mix these two solutions, this is essentially what I'm throwing together. 4 ions, each of which is continually surrounded by its own little hydration shell. They're electrically neutral. However, when I throw all these ions together into the same solution, then we get a very strong attraction between the silver ions and the chloride ions, and they precipitate out. They form a silver chloride lattice that is insoluble. We can see it sitting there at the bottom of the test tube. But the sodium ions and the nitrate ions remain soluble. They remain floating around in their solution. Now, if I can just remind you that when they are floating around in the solution, they've got their shell of water molecules, their hydration shell around them. They are completely unaware that anything has happened. This reaction has completely passed them by. They are known as spectator ions, or in some cases bystander ions, because they have just been swimming around watching the reaction happen. As a result of that, we can get rid of them. There's no point having them in the equation, because they start off floating around in solution and they end up floating around in solution. So we can write this equation as an ionic equation, and an ionic equation just represents what actually happens in the reaction. And in this reaction, silver ions, which were in solution, I draw a Q, and chloride ions, which were in solution, react together to form a silver chloride lattice, or a precipitate, and they're no longer in solution. So this here is an ionic equation to describe the reaction between silver ions and chloride ions. Let's take a second example. If I drop calcium carbonate or marble chips into nitric acid, I form a solution of calcium nitrate, and water and carbon dioxide is bubbled off. The first thing to appreciate is that all aqueous acids, all dilute acids, exist as ions in solution. So nitric acid is actually hydrogen ions and nitrate ions, both behaving independently in solution. So let's rewrite this equation in terms of its ions. Calcium carbonate is a solid. It's in a lattice structure, so it's not in solution, it's not independent ion, so it goes into the equation as is. I know that in my balanced equation I've got 2 hydrogen ions and they are in solution, so I'm going to write them out separately. And I form a solution of calcium nitrate. That is what my state symbols are telling me. So once again, my calcium ions and my nitrate ions are independent of each other. So I've got 2 nitrate ions. Make sure that we balance throughout. And I've got water as a liquid and carbon dioxide as a gas. So let's have a look at what has changed and what hasn't changed. Well, clearly the calcium carbonate has changed. We've gone from calcium ions in a lattice to calcium ions in solution. We've gone from carbonate ions in a lattice to carbon dioxide, and some of the oxygen's turned up as water. My hydrogen ions have gone from being ions in solution to part of a water molecule. They've changed. However, nothing has happened to my nitrate ions. They were floating around in solution at the beginning as part of nitric acid, and they end up floating around in solution at the end as part of the calcium nitrate solution. So rewriting this as an ionic equation, it would be calcium carbonate, always put in my state symbols, is reacting with the 2 hydrogen ions from the acid to form calcium ions in solution, and molecular water as a liquid, and carbon dioxide gas. And finally, at A level, there are many things that you are just expected to know, and this is really where it starts. You need to know the charges on your ions. You need to know, for example, that in group 1, if I were to take sodium, group 1 metals always form cations with a single positive charge. If I were to take oxygen, for example, the nonmetals in that group, group 6, all form an anion with a double negative charge. You should also know the formula and the charges for your compound ions, so things like nitrates, sulfates, phosphates, chromates, hydroxides. It gets more and more complicated and you'll build up that knowledge, but you should start to learn these formulae. Equally, you should have a feel for what type of ionic compounds are soluble and which are insoluble. So generally speaking, all nitrates and chlorides, most sulfates are soluble, but we have some exceptions. Silver chloride, lead chloride, barium, lead, strontium sulfates. Most carbonates are insoluble apart from group 1 and ammonium carbonates. All group 1 and ammonium salts are soluble. Transition metals, the ones that you should definitely know about, copper hydroxide, iron 2 hydroxide, iron 3 hydroxide. These were part of the ion tests that you learned at GCSE, so you know that they're precipitates, you know that they're insoluble. The copper hydroxide is pale blue, the iron 2 is pale green, and the iron 3 is essentially rust coloured. So start putting all this information together and get learning. If this has been helpful to you, then if you go over to Crunch Chemistry, I've got notes on this and practice questions. So it'd be good to see you there. If this has been useful, hit the subscribe button, the effortless way to support your studies. And by clicking the link in the description below, it'll take you straight to Crunch Chemistry School, where you can access my free maths skills course, complete tuition, and worksheets designed specifically to build your confidence and stretch you. Together we can do this.